Hi, I'm Mr. Huber, and in this video I would like to talk about exercise 1. The diagram shows a wedge ABCD XY, this one here. The base ABCD and the face CBXY are rectangles. I think that's quite obvious. ABCD is a rectangle, and obviously this front face CBXY is a rectangle too. The angle XAB, well, the one down here, is 90 degrees. BC is 9, BA 18, and here 15. Now calculate the angle XBA. They mean this angle here. Actually, they should label it like this: ABX. ABX. Normally, that's how you label this angle. Well, in these English books, they don't always follow that rule. But that's very easy to calculate because it's a three-dimensional shape. We have to work out this angle here. Let's label it alpha, that's easier. So it calls for a tangent. Tangent alpha is 15 over 18. Why is that? Opposite over adjacent. So we need the inverse function. So alpha is arc tangent 15 over 18. Inverse function, or tangent to the minus 1. So let's type this in. Shift tangent to the minus 1 of 15 divided by 18. Well, that's 39.81 degrees. Alpha is 39.81 degrees. Now, calculate the angle between the line XC and the base ABCD. So for that, we need to work out the length of XC. How do we do that? That's quite easy, because you have this rectangle here, C, B, X, and Y. So XC or CX is easy to calculate. This is 9. And then we would have to know the length of this line here. This line here. We don't know that line for the moment. Well, let's label that L. This is 9 centimeters. Let's work out L first. Well, L is, in this triangle, 15, 18, everything in centimeters. This is L. Well, you can use Pythagoras for that. L is 15 squared plus 18 squared and the square root of it. So let's type this in. Square root of 15 squared plus 18 squared. That's 3 times the square root. 3 times the square root of 61, which is approximately 23.43 centimeters. Well, you can store this value if you want to. Let's store it. Shift, store A. Okay, so this is value A. Well, now you can work out XC or CX, because it's XC is 9 squared plus L squared. So, and the square root of it. So you can use this. And your A, because A is 3 times the square root of 61. So let's type this in. It's the square root of 9 squared plus, recall A squared. That's 3 times the square root of 70. 3 times the square root of 70. Well, in here you have 9 squared plus 3 times the square root of 61 squared. Either you type it in like this or you use the stored value. You shouldn't use the rounded value because that will lead to rounding errors. Now you have this line here. The length of this line is 3 times the square root of 70. So let's store this. Shift, store, B. Okay, I've stored it as B. Now, it's easy to work out this angle here. Look, you have the diagonal down here, you have the 15, and you know this, okay? It's very easy to calculate. So let's call this one beta. Then tangent. No, it's not tangent, it's sine beta. Why is that? Because this is the opposite and this is the hypotenuse, because the right angle will be down here. This will be the hypotenuse, the longest side. So it's opposite over hypotenuse, which is obviously 15 over the hypotenuse, which is 3 times the square root of 70. Now you need inverse sine for this, or arc sine of 15 over 3 times the square root of 70. I could use B for that. So arc sine to the minus 1 of 15 divided by B, recall B, and that's 36.670 degrees. So beta is 36.70 degrees. There are many ways to calculate this. You could have calculated this diagonal down here, and then you could have used the tangent, this over this. That would have been possible too. Look, you could have worked out this diagonal down here. Let's label it D. D is 18 squared plus 9 squared, square root of it. So square root of 18 squared plus 9 squared. That's D is 9 times the square root of 5. And then you could have used for beta, tangent beta now. You'd have said, well, opposite over adjacent, so 15 over 9 times the square root of 5. Now I'm going to type in the 9 times the square root of 5. I need the inverse function, tangent to the minus 1, or arctangent. I prefer arctangent. Okay, tangent to the minus 1, shift tangent to the minus 1 of 15 divided by 9 times the square root of 5. Close the brackets here. And we get the exact same thing again. Beta is 36.70 degrees. This would have been a shorter method. You can choose either way, it does not matter. I hope it was not too difficult. See you in the next one.